All right, here's another bearing problem. A man wandering in the desert walks 3.3 miles southwest. So we're heading west. So let's have him start over here on the right, and let's draw in our coordinate axes on where he starts. Is that about right? No, let me draw it a little bit straighter. All right, there's my coordinate axes. I draw it like a dotted line or lighter, and so he's going to walk south 44 west. So the angle for 3.3 miles. So let's say he walks there. So 3.3 miles means that this number is 3.3 miles, and this angle is 44 degrees. Southwest. That's how you do the bearing. Southwest. Now, what I always do is to draw from this new point, I draw another coordinate axis so that you can see what your angles are, because that's usually the trickiest part here. So that from there he walks northwest, 55 degrees northwest. So this angle, let's try to draw it somewhat accurate, and it's only 2.2 miles, so not quite as much. Try to draw the lines about right so that you know where you're at. So that angle is your 55 degrees. And then it says, at that time, how far is he from his starting point, and what is his bearing to the starting point? So we're going back to the starting point. We want to know what that distance is. And then we also want to know what the bearing is. So let's first do the distance. Well, the first thing you need to do is find out what the angles you have here. Well, if this is 44 up here, then this also is 44.
Oh, right. Okay.
So that's the trick, and that's why I draw those coordinate axes in there. So that's 44 degrees. So in total, this whole angle is 44 plus 55. That's 99 degrees. So that angle, entire angle in here, let me change colors so you can see it. This whole angle is 99 degrees. And we know that the side lengths are 2.2 and 3.3. So you can use your law of cosines to find x over here, or let's call it d, the distance. You could use the law of cosines to find d, because you know that d squared, by the law of cosines, equals a squared, we'll call this a, and we'll call this b. A squared plus b squared minus ab cosine of d, and angle d is 99. So just plug in all your values in there, or better yet, use your calculator and use the store button, and then just use, or if you have and then don't forget to take the square root of that. So d equals the square root of that whole mess. Let's find that. So we got d equals 4.243, which makes sense. And now to find the bearing, again, let's draw in that little, this time I'll use blue because we're going to see this better. Let's draw in the coordinate plane. Sometimes it's hard on this to draw like something like so. And so we want to find the angle. We want to find the bearing that it's on. So you have to be careful. Make sure you draw things correctly, because sometimes it's hard to tell where you're at. So that's in my mind the trickiest part to this. So you want to try to draw the angles as correctly as possible, and the side lengths proportionately at least. So we want to find this angle right here. We're going to say, so let's call that angle, we'll call it A. Have I used A yet? I don't think so. We're going to say that he is north, whatever A is, east. That's the angle that we're talking about, that he's going back. So to find that, well, I have some other values over here. You can see this angle right here. I can find that angle. Right? That angle is going to be the same as this angle, which is the complement of 55. So what is that? 35? So this angle is 35. That's 35 degrees. And now I can find this whole angle right there by using the law of sines. on that big triangle that I have up there. You follow what I'm saying? So I know that the sine of 99 is to D, which is 4.243, as the sine of, let's call that angle big B. This whole angle is big angle B, is to 3.3. So we can find B. Go ahead and do that. Find B. And that angle we find it to be 50.193 degrees. And so I subtract 30 from that to give me, let me put a different color on this purple. We'll call that angle Z. So Z equals B minus 35 degrees. So subtract 35 from that, and you tell me what you get.
15.193.
15.193. So that's that angle. 15.193. So now I'm going to take A. Remember, I want A. There's A over there, which is the complement of that number, because that is a 90-degree angle right there.
Mm-hmm.
So I found Z, which is 15.19. I subtract that. What did we call it? A. Well, I shouldn't really be calling it A, probably, because A is technically, I called this angle A, so that's technically A right there. Although, wait, is that no, it's not the same thing. So let's not call it A, let's call it K. I don't know. So the bearing I want is K, that angle is K right there. So K equals 90 minus 15.193. So K equals
74.807.
which is 74.807. So that's my bearing number. So now I write, what is his bearing up there? His bearing is north 74, we'll round it to 1, 74.8 east. North 74.8 east. That's my answer if I did everything correctly.